Hello, hi guys. So this is PSPM KMS 20 for batch 20 and 21 lah. Okay, so this is question 7A. So this is on chapter 8 because this is the 7th question. Okay, so first because in chapter 8 we got so many subtopics. So we need to first identify which subtopic this question represent to. Okay, so if you go through the question, in double slit experiment, the incident wavelength is 660 nanometer, the slit separation is 0.25 millimeter, and the screen is placed 90 centimeter away from the slit. Okay, so for this one, which case do you think it is? Okay, so you go through the question in double slit experiment. So as I said, the question is going to give you everything you need. There's nothing wrong with the question, just that you didn't know. So this is young double slit. Double slit. Okay, so for young double slit, as I said, you can refer back to the list of equation. So I divided the equation into several chapters, right? Okay, so you can refer like the first equation will be on constructive m lambda d over d. The other one for destructive. So this is constructive. This is for destructive. Okay, so second one. For young double slit experiment, is it in-phase coherent sources or anti-phase coherent sources? So because it's a young double slit, it comes from one source. It passes through two obstacles. So it is in phase. Okay, then third question. Is it the question asks you for constructive or destructive. Okay, so with the question, calculate the distance from the second to the third destructive interference. So there's a word destructive here, so therefore it is destructive. So from there we can simplify that the equation we need to use is this one here. So lastly is the equation ym m plus half lambda d over d. Okay, so calculate the distance from the second to the third destructive interference range. So the second and third is consecutive, means that first comes second, then comes third, means that they are next to each other. So other than this equation, you can also use delta y equals to lambda d over small d. So from the question, you are given the lambda, which is the wavelength, slit separation. When they are talking about slit only, means that this is small d. So the 90 centimeter for the screen, so this will be the capital D. Okay, so we go through one solution first. So first one, so delta y, so lambda is 660 nanometer. Remember that everything must be in SI unit. Capital D is 0.9. This is small d is 0.25 millimeter. 93. We're going to press my calculator first. 9 divided by, so 2.376, then 93 meter. So that is one way of answering it, because this kind of question is going to give you just few marks. I think about maximum 2 marks. Okay, or else you can use this equation here, but for this equation, you have to be careful. The second and third destructive interference. Second destructive interference means that the number of order is m equal to 1. Third dark fringe, number of order is 2. So basically, you delta y equal to y2 minus y1. Means that you are able to calculate individually using this equation down here. So for the first y2, you just sub this as 2. Then sub number of order as 1, get the value for y2, then y1, then just minus the value. So next you're going to get the same answer. If you really have no idea how to do it, you can try it that way. Okay, if you got lucky, because like delta y is the same for anything, means that if you calculate it for the second, or you got it wrong, means that for second dark fringe, you make it the number of order is 2. So the third dark fringe, number of order is third, you got it wrong. So if you minus, the value will be the same. but then the concept is wrong, so your answer will be wrong. Okay, so chapter 8 is so easy, don't worry. Good luck guys.